and HBase. So why is Flume awesome? Well, you could as well do the whole thing with like a shell script, right? It's pretty simple. Do it with a shell script, but I don't think your ops teams will be too happy with doing that. Like, they're going to complain that, okay, the shell script broke and we had to fix it, and we just couldn't get out of the line and come and fix it. So the idea of Flume is to be scalable, and it's primarily targeted at event data. So one of the best examples for event data is logs. If you use log4j or log4cpp, the way it represents a log event is actually as a single unit of data called an event. So Flume is meant for things like that. Flume supports dynamically and contextually routing the data based on the data itself. It allows pluggable interceptors which can actually inspect the data and say, hey, it should go to Hadoop or HBase or cluster 1 or cluster 2. And it's built to be low latency and very high throughput. Configuration is extremely easy. Java properties file, that's it. No XML, no fancy stuff. It's just Java properties file. It's productive out of the box. That's the most important part of it. Most of what you would need is already packaged into Flume. It's highly unlikely that you would really need to write code to actually run Flume directly. And best of all, it's open source. Flume right now is in version 1.3.1. It's actually called Flume NG when we started off from about a year ago. Flume OG or any version of Flume below 0.9x, below 1, that's 0.9x, was actually the original version of Flume, and we learned a lot of lessons from that. And Flume NG was practically a rewrite of the entire Flume system. So the lessons are up here, and I don't think we need to actually discuss it, but those lessons are actually what helped us design Flume as it is today, and we are still learning from it. Flume is continuously improving, and from 1.0 to 1.3.1, if you look at the features and number of bugs fixed, it's enormous. It's like Flume is now at 1900 or something in the Jira count, and when we started off with Flume NG, it was actually Jira 728. So in less than a year, we fixed over 1,200 issues, and many of them were actually massive features, not just bugs. So in terms of Flume NG, the simplest unit of deployment is an agent. There's nothing bigger, there's nothing smaller. It's just an agent. Every agent looks exactly like this. Source, channel, sink. A source is where the event enters Flume. A channel is a buffer, and a sink is where the event leaves a Flume agent. So the idea is that the channel is a temporary buffer for storing the events. The whole idea of doing this agent structure is to do something like this. Now we have a multi-tier configuration where each of these is actually just an agent. So what you do is you want to make an agent talk to an agent. You use an Avro sync or an IPC sync. We actually just started supporting Thrift. So you use an Avro sync or a Thrift sync coupled with a Thrift source on the next hop and get them to talk to each other. And the terminal agent, the last guy here, he talks to HDFS through an HDFS sync. So because every component in Flume is pluggable, we didn't really have to create multiple different roles. Every agent can do any of these roles as you configure it. The idea here is that an application talks to a bunch of Flume agents. Now depending on the number of applications and the number of machines actually talking to the first Flume tier, you probably would need a few machines there. You aggregate from those machines into a smaller set of machines and finally to your destination like HDFS or HBase. And I think we have actually an Elasticsearch sync as well, so you can actually write data even with Elasticsearch. Basic concepts in Flume is, as we discussed, a client and an agent. A client is what generates the data and writes it into Flume. An agent is Flume itself. So examples of clients are like log4j appender. We have a log4j appender which you can just drop the jar into your class bar and use the log4j properties file to actually say, hey, that's my appender. and Flume will do the rest. All you need to do is to configure the log4j vector to actually point to the first Flume source. Now, we also provide a client SDK. The client SDK is basically meant to actually integrate with your program. So you basically use a bunch of APIs which Flume provides to actually drop the data into the next tier. And we also support a client-based operation where you can actually just directly write to Flume by HTTP or syslog. But there are some caveats when you use something like syslog, it's a file and forget protocol. If Flume is for some reason not able to get the data into its channel locally, it will just throw an error and we just exception Flume's logs. And there's no way to actually send an error message back to the guy who sent the data because syslog doesn't have support like that. So client-based operation is restricted. It's quite restricted, but it supports actually not having to change your own application. Now, a Flume agent has three different components, major components. There are minor ones in between, but there are major ones which are the source, channel, and sink, as we saw in the last picture. So, when a Flume agent is configured, Flume does a minimal syntactical validation, and each agent really must have one channel, one source, or one sink attached to that channel. You could have any number of sources, any number of sinks, and any number of channels. But okay, as long as you keep your hardware, supported. Like you have 16 cores, you probably don't want like 5,000 sources because each source runs on its own thread, and the source itself could actually run these, a bunch of threads. Maybe a thread pool inside, like the Yahoo source. In which case, you're going to actually run out of threads and your system is going to be running. Now, the concepts we talked about, this is how it works. A source writes to a channel, and a channel basically stores the event until a sink clears it out. Basically, a channel is a passive component. The channel does not force the events to go out. The channel keeps the events as long as the sink doesn't take the events, right? The sink takes it out, the channel says, okay, the sink is taken out, let me throw the event out. I don't care about it anymore. So, you basically connect source, sink, a sink to the next hop, and have multiple hops, just like that, right? A sink, RPC sink talks to the next RPC source. And in a normal case, you would have image 1, where all your channels have like a few events, not a massive number of events. But suppose you have one agent go down, maybe the JVM crash, maybe the machine just went offline. In that case, what happens is, instead of actually blocking the data from entering the Flume pipeline, Flume starts buffering the events in the channel on the previous hop, the hop just before where the channel died. At that point, the channel starts filling up. If the channel fills up even on that agent, this actually percolates a failure to the previous guy. So it allows you to manage your cluster in such a way that you can afford some downtime. Depending on how you plan your capacity, this downtime can be anything, right? If you have a million agents, you could as well have downtime for a year. But if you have only one agent, you probably won't have downtime for more than a few minutes, depending on how fast you write it and through. The idea being that downtime should be predictable, and if you plan your capacity well, you know how much downtime you're going to get. Flume is actually fully reliable. Once agent 1 gets the Flume, gets the events, then Flume's not going to lose it. But there is a caveat, which we come to later. But the idea is this: every sink basically starts a transaction with its channel. Every sink is attached to only one channel. So every sink will start a transaction with its channel, take a bunch of events as a batch, depending on how you configure the sink. Maybe it will just take one event, maybe it will take 100, depending on the configuration. It takes the events, sends the events down to the source. The source now gets this batch of events, starts a transaction with its own channels. It could have multiple channels, not just one. It starts a transaction with its own channels, puts the events, and commits the transaction. If the transaction succeeds, it tells the sink that, hey, you know what? The transaction has succeeded. I've got the events in my channel. Do whatever you want. The sink at that point will end the transaction that started earlier. When the sink ends the transaction, the channel will decide what to do with the events. In most cases, the channel will just dereference the events or mark them as taken. In both part, writing in the channels, the channel basically dereferences the events. And if in case of memory channel, the memory channel is just cleaned up by GC. But in case of the file channel, which is the right-hand block, we actually clean it up periodically every 30 minutes or so. 30 seconds or so. Now, there is also built-in load balancing and failover support to communicate between two agents or more than two agents. So if you have tier 1 talking to tier 2, you could load balance tier 1 syncs between all of tier 2's agents so that you don't always write to the same line. Now, reliability semantics. Reliability semantics actually come from the channel. So if the two major channels which we currently recommend to users is the memory channel and the file channel. The file channel is actually a persistent channel. So if that particular machine fails, when the machine comes back up and you start the Flume agents, the data in that particular machine, that particular agent's channel will be available to you at that point in time. So it's essentially something like saying that, okay, this is not available as long as this machine is down, but when it comes back up, it will be available again. So the data is not lost. It might be delayed, but it's not lost. In case of memory channel, it just holds the events in memory. So if the channel, if the agent dies or if the machine dies, the data is gone. You probably don't want to use this position to read the data. Now, if you're using the RPC clients to write data to Flume, the RPC clients would just say, I don't write events out if the source actually fails to write events out to the channel. At that point, the RPC client will throw an exception and the client code which integrated with the RPC has to handle the failure. So if such a failure happens, if you really need the data to be retried, you actually have to call the RPC client again, maybe with the back off and things like that. The Flume client SDK actually supports a lot of customization. It also supports load balancing and failover. So if your sources start, like if your first tier starts failing, it could load balance between multiple different machines. And if any of them are failing, it will go to the others. So configuration is using the Java properties, but configuration sort of looks like this. Every agent, you basically specify the sources, and then you specify channels and sinks. And with each source, you specify its own properties, like which port it has to bind to, and its branch size, what type it is, and things like that. Then you specify the channels. Again, same. You give it some property, like what is my right-hand block folder, or what is my checkpoint folder. And in the sinks, same thing. You actually specify a bunch of sinks, and you configure it. For each of the sources, you can specify more than one channel. Each sink has to actually have exactly one channel. A sink cannot read from more than one channel. A sink will read exactly from one channel. Flume uses a hierarchical namespace, so properties file uses something like this. First, you set a few components as active components. Those are the components who will be activated in this particular agent. So you say agent1.sources is equal to source 1, agent1.channels is equal to channel 1, agent1.sync is equal to sync 1. Now you can have multiple sources, multiple sinks. They're just space separated and you just drop it in. So you can have source 1, space source 2. And then you say agents.sources.source1.type. So it's basically hierarchical and you can configure it using Java properties, and it's actually the configuration system is now extensible. So you could actually, if you're willing to write, you could do something like Zookeeper configuration, so you can just deploy Zookeeper and drop the configuration to user agents, things like that. But yeah, the code is not there, you probably have to write it yourself. So in case of the Flume configuration, there are a few rules. The first and most important thing is that your properties file will actually have a configuration for more than one agent. It is actually common with users I have seen that the configuration file is actually a single file for all their tiers. They just name their agents differently. So when you start Flume from the command line, you specify the name of the agent, and Flume will only activate that particular agent. Flume will activate only the components which belong to that agent. So in this file, you can actually see agent 1 and agent 2. But if you start from the configuration, you say, you know, the name of the agent is agent 1. Only agent 1's components will be picked up. Agent 2's components will be ignored. So that allows you to basically have one single configuration file for your entire deployment. You don't have to have different files and things like that. And Flume is configuration aware. So each time you actually change your configuration file, Flume will automatically pick up the changes and restart the components. Flume actually does not like hot deploy the components, but instead it will stop the Flume agent internally, once to restart the JVM, it will stop all the components, pick up the new components, and then restart all the components again. So a typical deployment looks something like this. The first set, which you see is tier 1. So tier 1 would have a large number of agents to read from geographically diverse clients. Or it could actually just be reading from local clients, but if they are huge in number, you probably want a huge number of agents because these are network calls and you probably want to move the data out as soon as possible. In the second tier, you actually aggregate it. And the third tier, you reduce it to a few agents who actually write it to HDFS or HBase. So this allows sort of a steady state of inflow and outflow. So if there is a huge number of events suddenly being generated at 9 o'clock in the morning because everybody is logging into Yahoo News, and Yahoo News has this huge number of click-through events which come in, you probably want to send them in as soon as possible to HDFS. But the problem is, you don't want to overload HDFS. At that point, if HDFS is not reading the data out as soon as possible from the last year, Flume will actually slowly back the data up and make sure that HDFS does not crash and like your data is not lost and Flume does not come, you know, the entire cluster does not come down by backing up the events in the channel if things start building up slower. So let's look at various components within Flume. The first one is the source. Source is actually what gets the data from the previous tier. The previous tier can actually be an application, log4j, syslog, or even a Flume agent itself. There are several different sources. Arrow and Drift are the IPC sources. Arrow is actually more nested and stable. Drift is just added about a week ago. So I don't know if it's stable. It was just added a week ago. Now it will be available in the next release. Arrow is already available in the current release. A small directory source is basically a source which picks up files which are in a particular directory. And it basically assumes those files are actually immutable. So usually what we recommend that you do is like when you rotate your logs, you move out to a different directory which the small directory source reads from. And it will read those based on how you configure it to read. The default is it just reads at the end of the line, but there's also a way of reading arrow data. You can actually plug in your own serialization format and say, okay, this is how you read the data. HTTP source is basically something that just listens at an HTTP port and says, you know, give me your data in HTTP format. But primitive we actually already have a JSON handler, so it accepts events in JSON format. It accepts, we have another source which accepts events from JMS. We also support syslog, TCP, and BDD. Netcat is sort of like a testing source to make sure that things work well. And usually we use it for testing the channel and things like that to see if, you know, if events we copy the source actually ends up the same side of each other. Exec source is actually a source which can execute a particular command and take its output and drop it into the channel as events. How does the source work? The source basically reads data from other lines or other things, stores the data into the configured channels, and it's actually asynchronous to the other end of the channel. The source runs on its own thread, so as it gets data, it can keep writing the data. So the source doesn't care if the channel is being drained or not until the channel actually gets full. If the channel gets full, the source won't be able to put the end of the channel and throw an exception. But the source doesn't. The source performance is completely independent of how fast the data is being cleared out from the channel. Source also uses transactional semantics to drop events into the channel. So when the source actually starts a transaction and writes events and completes the transaction, it acknowledges it with the sync and with the previous hop sync. At that point, the previous hop sync can actually delete the data from its own buffers. So yeah, this is sort of visualization. Begin a transaction, move the events out of the channel, commute the transaction, and then basically from previous agent. The source supports batching, which is usually recommended in case of persistent channeling the file channel, because at the end of each transaction, the file channel is going to actually f-sync those events to disk. Each f-sync is expensive, so if you start doing one transaction of size 1, your file channel is going to perform really poorly because each time it's just going to sit into an f-sync. So we recommend usually using a batch of events and just writing out a batch of events at one shot. The source is where you actually plan out the flow, where you decide whether your events are going to cluster 1 or cluster 2 or HDFS or HBase or both and things like that. So a source has a component called the channel selector which allows you to actually say inspect my event and then send the data out into with one of the n channels, and the channel could be instead to write one of the 6. Flume also supports interceptors. Interceptors are actually lightweight processing of data. We don't recommend that you do heavyweight processing here. It allows you to transform the data, but we don't recommend that very fancy transformations are done. So a source actually writes an event out into a channel processor. The channel processor is an internal component which actually passes the event out to a chain of interceptors. And then eventually the interceptors transform the events and return it back to the channel processor. At which point the channel processor passes the events into a channel selector. The channel selector decides where the events have to go. And then it says, okay, it has to go to channel 1 and channel 2, or it has to go to only channel 1. At that point, you decide, okay, here, write to channel 1, write to channel 2. Now, channel processors, channel selectors allow you to make certain channels optional and certain channels required. If the event fails to write to even one of the required channels, then the event is going to the transaction is going to fail and the previous link is going to get a fail. But if it writes out, if it fails to write out to an optional channel, it's perfectly fine because it's optional. It says, okay, it will log it saying that I lost this event, it couldn't write it to the optional channel, but yeah, maybe it is optional. So a channel selector is where the channel is selected to which channel the event actually goes out. So the default channel selector is a replicating channel selector. So you say, channels for a particular source is 1, 2, 3, 4, 5. It's actually going to write out all the channels. But if you actually use a multiplexing channel selector, it allows you to inspect the event headers. And if the value of the header matches any particular value, it will send it to that particular channel. So as you can see, it says like selector.time is equal to multiplexing, and selector.mapping.foo is equal to channel 1, selector.mapping.bar is equal to channel 2, default is equal to channel 1, and header is your header. So it actually inspects an event, says, okay, let me read your header. It looks at your header and checks, okay, is the value of your header equivalent to foo? If it is, it drops in channel 1. If it is equal to bar, it will drop in channel 2. If it is neither, if it is not foo or bar, it's Yahoo, it will just drop in the default channel. So a multiplexing channel selector sort of allows you to decide where your channels events go based on priority or however you define. We'll quickly look at some of the built-in sources in Flume. There are the asynchronous sources where the clients do not actually know of the failure because there's no way of actually informing the client of failure. The two asynchronous sources, actually syslog is 2 sources. So you have 3 sources which are asynchronous, which is the exec source and the syslog source. If an event fails to go to the channel for any of these sources, the agent or the client that's sent it by syslog or the application that is dropping the data out into Flume will not actually be able to realize and resend the data because there's no way to actually tell the application to resend the data. There are synchronous sources. The synchronous sources actually read data from primarily by IPC, except for JMS and HTTP, which actually read by those protocols. In case of HTTP, it will return the corresponding HTTP error codes. In case of JMS, it will return according to the JMS protocol. There are also 2 sources which actually give us support to the Flume OG format of events. So those sources are actually not recommended for use unless you're actually using from OG to NG transition or something, but no one really uses it for actually transferring real data, except from OG to NG. So there are two RPC sources, Arrow and Drift. They are almost identical in configuration. The only difference is actually the type of source. You actually say it's Arrow or Drift. And all you have to do is say, all you have to pass in is line and port, is which host name and which port is actually listing on, and then the channels it has to. Every source needs a set of channels. So these are the source specific configuration. Now, if you want to listen to if you want multiple channels, you actually specify RPC source 1 that dot channels is equal to and set of channels. Uses only TCP and it's basically an IPC source. So if the previous node sends a bunch of events which it cannot write to its channel for whatever reason, it will return failure. The previous agent will know that it couldn't write the data. The previous agent could be actually just your own application with an RPC client trying to write the data. Spooling directory source, as we mentioned already, is basically, it actually just does that, right? It sits and watches the directory. If new files get copied, it assumes those files are actually immutable. If the files change, it's going to throw an exception. So you basically roll your logs and move it to a different folder. At that point, you will read the logs and send the data over into the channel. The way it reads the data is customizable. You can actually say, you can actually ask it to read new lines as each new line is an event, or you can use Arrow container format. The configuration is again pretty simple. You can just say this is the directory that you have to read, and once a file is done, what you should do with the file. You can either never delete it, at which point it just renames it to the dot done at the end, or immediate. If you use immediate, it means that at the end of once it processes the entire file, you can just delete the file. Usually, you want to use immediate if you don't have a process controlling, you don't have a script or something that reads the dot files and deletes it themselves. HTTP source simply runs the web server. It listens to a particular port, and then you can supply the handler. There's a built-in handler which is a JSON handler, so it reads the events in JSON format, it converts it to Flume events. But it's basically an interface. You can plug in whatever you want as long as you implement the interface. And once you implement the interface, you transform it into a list of events and just return the list of events. So this is how the JSON format looks like. You pass in the headers and you pass in the body as a string. And we also support matching the HTTP source, so you can actually send an array of events, which is what we recommend because HTTP already has its own overhead, and if you send one event at a time, you're actually going to hit performance issues on the pipeline, which usually you don't want. XS source is primarily, at least in my experience, used to do tail mindset. So if you want to tail a file, we don't really directly support tailing files because tailing files is tricky, and you don't want Flume to miss events in a file just because the tail source had a bug. So this is primarily used for tail mindset. This can be used to tail log files, but you must understand that if a particular line of the log or a particular log event could actually not be written into Flume, what's going to happen is this thing will throw an exception saying I couldn't write it, but it won't try to read that again because it's reading from the stream, and once that part of the stream is read, it's not going to read it again. So again, the configuration is pretty simple. You basically specify the type and the command it has to execute. It also supports the batch size so that like 20 lines or 40 lines of the output stream is actually sent out together. JMS source will read messages from the JMS queue, convert them into Flume events and put it into a channel. It's pretty much similar to all the other sources in the sense that it basically gets data into Flume from one of the end formats it's supposed to. An interceptor is actually pretty interesting. Interceptor is supposed to basically allow you to transform your event. An interceptor gets a list of events based on a batch, and it says, okay, intercept this thing. Now, you could essentially do whatever you want with it as long as you don't start increasing the size of the batch which is sent in. If 100 events were sent into the interceptor, you have to return strictly less than 100 events or 100 or less events. can have an interceptor chain. So you basically, in your configuration, you say you have 5 interceptors per source. It will actually go in that exact same order, and eventually get the list of events from the last interceptor. Writing a custom interceptor is pretty simple. All you need to do is to implement the interceptor interface and then create a builder to it, a builder for it, and you just pass the builder in the configuration, and Flume will just build it and deploy the interceptor